My name's Tallman, and I'm going to talk to you today about Composable Healthcare. I work at Breezy HR, and we use Clojure and Datomic. And if you're interested in what you hear here, feel free to talk to us about joining our effort. So my agenda today, first I'm going to talk about a health information problem. Next, I'm going to talk about how we're underutilizing this new medium we have. And I'm going to talk about how we can battle complexity in that new medium. And then I'm going to give you a demo and a progress report of how that's going for us. So the health information problem. First, we need to take a step back. Health information problem can't be reduced to just relational algebra. Patients are sick and hurting, and a crucial part of the healthcare experience is empathy. This image here it's a painting called The Doctor from 1891. And I think it captures some of the compassion and the vulnerability in this relationship between a doctor and a patient. In some ways, this older painting seems very distant from medicine as we see it today. But we still have that connection with our doctors. We still trust them to relate what's wrong with us to us in a way that's helpful. But now there's all these other things. We have x-rays, genomic sequencing. Science is giving doctors more and more tools to better analyze this, and the doctors are being overwhelmed by the amount of information that's being spit at them through alerts and recommendations and changes in the ways they should treat different diseases. Medline Plus says that there's about 1 million medical journal articles indexed in there every year. And I have a hard time grasping just how much that is. So a little quick math, if we assume each of those articles are 10 pages apiece, and a page is roughly 1/10 of a millimeter, we end up with, if we stack them on top of each other, about 1,000 meters. In context, we see that with the world's tallest buildings, topping out at about 800 meters. And I put in here Portland's Wells Fargo Center at 166 meters. It'd take about 6 or 7 of them to get as high as these piles of papers that are produced every year. And also, if you compare it to Mount Hood, it's almost half of the prominence of Mount Hood, as you can see in the distance there. So much information. And it's not just the information. Doctors must keep up with a whole community of people trying to coordinate care. We have doctors, nurses, caretakers, medical researchers, insurance companies, public health agencies, and other parts of the government, and the patient and their family. So many lines of communication is going to make a pretty complicated space. I'm going to zoom into one part of the healthcare experience. And that's the medical record. It's basically the central repository of information that a doctor keeps about a patient. Now, these medical records are called charts, and they have your lab results, your family history, your vaccination record, and about any observation the doctor makes about you. Inside the charts are encounter notes. They look a little bit like this, and they document the story of what happened when the doctor sees you in the exam room. And you can see here, this is very readable for doctor's handwriting, but there's a 37-year-old patient here with a cough and tightness in the chest, and they all follow this general form of observing what's subjective, what complaints the patient came with, objective things, tests they did, etc. And then they make an assessment of what they think's wrong and a plan of how to make the patient better again. A couple of years ago, most encounters looked like this. Paper scribbled with, the doctor's famous penmanship. But something's happened in the past 6 years. If you look at this graph, you can see that back in 2008, there was one state that had over 20% usage of electronic medical record software. And as you go 2011 and into 2014, we see that Every state has over 60% usage of electronic medical record software. Now, this is the only image of medical record software that I could get the use to use here. But you can see the point here. It's basically taking the same things that were on that paper chart, the complaints and everything that the patient described, and now it's typed. It's legible. There's advantages to billing. There's improved communication. You can prescribe and order labs electronically, and it's a big win for everybody involved. In 2009, one of the main reasons you saw the huge uptick in EHR usage is the federal government basically paid each provider who wanted to adopt electronic health records $18,000 to gear up their system. And there are thousands of EHR products now. Some of the vendors have tens of thousands of employees. And many of them are doing really interesting things right now. But there's one strange thing. Why did the government need to give incentives for people to use health record software anyway, if it was so much better for the doctors? The world didn't need incentives to adopt iPhones and iPads. Enterprises didn't need incentives to adopt resource planning software. So I think we should take a closer look at why those incentives were necessary, and maybe it'll show us other opportunities to improve. So some of my progress report here is there are many doctors that report of the amount of patients they could see a day when they used electronic health records dropped from 25 to 30%. And there's more and more information that's being required as the stages of meaningful use ramp up. And it's starting to jeopardize this human relationship between the doctor and his patient. Patients commonly complain that the doctor's typing more than talking to him. And doctors are feeling like they're secretaries. Now, many people are looking for big data to solve all these problems. I'm not so sure. One other symptom we see is there's this new job position that's suddenly spraying into the world, and they're called medical scribes. It's basically someone who follows the doctor around, and their job is to attend to entering data in the EHR while the doctor attends to the patient. Doctors love it. But I think scribes demonstrate something. EHRs are not being used to make decisions. I mean, sure, they give you warnings if your drugs conflict. That's huge, and that's good. But EHRs are primarily a log of what the doctor does. And I think that's a shame. Dr. Farsad Montessori makes a point that even though most doctors don't realize this, most primary care physicians, that they could be seen as a CEO in charge of roughly $10 million in medical spending, each doctor. And what those doctors need is a lever. You know, as Archimedes said, if you give him a place to stand and a long enough lever, he'll move the world. That should be our response to this data. And so I want to talk about what it would look like to use this fulcrum of where the doctor and the patient are together making medical decisions. So now I'm going to talk about the new medium. This is heavily inspired by Brett Victor and even more so the work done by those original people in Xerox PARC. It's funny how this stuff is so old and new at the same time. In 1968, they basically made a personal computer ahead of anything. They made the mouse. Most of the interactions that you know today were made in that period of time. And we are underutilizing that medium. This, I am sure, is not what Doug Engelbart had in mind. And we can kind of see it here. I imagine a picture of a scribe writing on his sheet of papyrus. And we have so much more potential of how to interact with the knowledge. I have a quote here from Doug Engelbart. And he says, this is about augmenting the human intellect. And he says, "We do not speak of isolated clever tricks, that help in particular situations, but we refer to a way of life in an integrated domain where hunches and cut and try and intangibles and the human feel for a situation can usefully coexist with powerful concepts, streamlined terminology and notation, sophisticated methods, and high-power electronic aids. Now, that's not something that even programmers would generally characterize their environments as. And doctors, the situation's even worse, just entering text mostly. So I want to make our requirements more stringent for how we'd use this new medium. So I envision a world where our users, the doctors, can touch and shape this knowledge. They can get real-time visible feedback on what they're doing, and they can allow sandboxes so that each of them can explore ideas on their own and then share them back with other doctors if they work and drop them if they don't. And this brings me to the title of the talk, Composable Healthcare. And so what's a Clojure talk without a definition? But compose, which means to put together or construct. But the definition itself is not important to me as much as the connotation. Most of the time when we think of compose, we think of either functions or music. And there's this underlying idea of reaching for some sort of order or beauty underneath it. We see Rich's idea of things can be composed in different ways, and how they're composed really affects how the system operates. And so I want to take this, and we've talked about composing functions. I want to talk about two things. How can we compose knowledge and people? So we see that again. All of these people who are involved in the medical process have things they want to be done in that medical encounter. The people in the billing want to make sure the doctor stops using that wrong ICD-10 code. The medical researchers want to make sure the doctor will fulfill their medical protocol. The specialist they're referring to wants to make sure that they did that lab order that they need in order to not make the patient wait. Now, that's a lot of people, and when you have a lot of people and a lot of things, it's very easy for things to get tangled up. And so we are going to go back to one of the most commonly quoted Clojure papers. Well, it's not a Clojure paper, but the Clojure community quotes this paper often. And it's Out of the Tar Pit by Marks and Mosley. And they give us two categories for complexity. One of them is essential complexity. That means it's the essence of the problem. This is you can't get rid of this. And accidental is, in the ideal world, all these other things we manage that we could get rid of. And they give us a determining factor to really see which category it falls in. And really the question is, does the user care about this? Does the user see this in his informal specification? And that's where you start to see things like whether I use microservices or not, or an atom versus a ref, or whether it's concurrent or sequential. The user, in the end, most of the time, doesn't care. And he goes on to explain different categories for this complexity. We all know state. One of the ones I want to talk more about is control. And control is basically the order in which things are done. They make a very strong statement that control should be eliminated in their ideal world. And that state should be the input data the user enters, and everything else should be derived from logic. And I want to see how close we can get to that using Clojure and ClojureScript and Datomic. So they introduced functional relational programming, the other FRP. And basically there's essential state, which are a set of relations. It's what's in the database. And in our case, it's going to be a Datomic database. And then there's the essential logic, and that's these relational algebra extended with pure functions that you can use to derive any of the other information that you'll need. So our essential state. Imagine each of these boxes are an entity. This is a medical condition. and it has an identifier, it has a subject, which is a patient it points to. And imagine a large graph of all of these entities and their attributes in a database. And the concept would be, this would be our essential state, and we would be able to annotate any other attributes on here based on the results of a query. This is similar to a materialized view. If you use Postgres, you can make a whole new table based on a query. And so it's similar expression as that. So here's an example of, in our system, what it looks like to make this logic, to derive new data. So we allow the user to build up this statement of, when there's an encounter that has a condition, which has the code, these are each attributes that you would see in the page before, of streptococcal sore throat, then it's going to add this new attribute, which is suggest to the side, and it's going to suggest a history of present illness, which is a section of the encounter, which has a condition of complains of cough, and the fact that its certainty is known absent. So with this system, you can build up these suggestions from any part to any part. Now this data this schema uses something called FHIR. It's the Fast Healthcare Interoperability Resources. It's this new RESTful, extendable, data-described API that HL7 is doing. If any of you have been in healthcare, it is way better than what we're used to with HL7 version 2 and HL7 version 3. And it gives us all of that. We read this directly into generate Datomic schema. And so anytime the schema changes, we can generate a new schema in Datomic. And here's examples of other rules. So if you have an encounter that has streptococcal infectious disease, then you can suggest a prescription that contains a certain ingredient. And I'll demonstrate later what it looks like to use this in production. Now, because this state, this logic, is not just a function, we can derive it in many different ways. We can take this data that describes this logic and we can generate Datomic queries. We can generate a function that will return this result, and we can use a service that we have that's a rule engine to derive this state and keep it up to date with changes in the database. And our architecture looks like this. Basically, we have a set of clients. They connect to servers just like anything else, and they ask for a resource, and they can subscribe to it. Now, anytime there's a transaction, you can see that arrow would be followed. The transaction goes to Datomic. Datomic state changes. It follows the arrow back to the servers and will update any other client that had a subscription to that resource. And the information also goes to the rule engine, where it updates any derived state that needs to be derived, which also goes to the server. Basically, this gives us the opportunity to use something we call Storefront. Now, Storefront gives us basically an API that's like Datomic in our browser. So we will use something similar to Datomic's Entity API, and it will, in the background, record every iLookup you've done, and it will batch request every one of those datums that you looked at and subscribe to it. It's very similar to what Facebook's Flux and Netflix FileCore is doing. It lets the client not be a full peer of the Datomic database, but only take down the parts that it needs. And it allows us to update in real time. By default, as we just use the regular map interface, everything's subscribed, and it will re-update the React component every time a change comes from the server. We have OM cursors for basically doing an optimistic commit. It's not the best idea, but you can basically do OM transact and change the data structures, and it'll get serialized into a Datomic transaction and get verified that it's valid on the server. And you'll see the results already optimistically before the commit comes back from the server. But what's most important about this is, as the user, you no longer are controlling when the data is loaded. You no longer have to explicitly set up what is the shape of this atom that I'm dealing with at the base of my application. And so I'm going to show you a little bit of code of what it looks like. So we're going to talk about a prescription section. Like this is a section of a medical encounter where there's prescriptions. And you can see we're just doing the standard API of GETs. At the top here of the prescription section component, it's this is quiescent, by the way. We get the current database, and we pull the encounter out by doing a lookup on the ID, the same Datomic interface. And then we just pull everything out from there from maps. And this is a current database, so it will be continually updated as information from the server comes in. Now, there are some caveats to this. So what happens as you pull the data? Well, the first time you pull it, it's not going to be there on your client. And so that's going to end up, it'll go through another React render frame until everything is there. And so there's a trade-off of whether you can plan up front to get all this data here, or just have like a REPL-like experience where it gradually builds up the page as it's doing it. But you'll see it's pretty fast even in that case. So on this page, here zoomed into the same component, and we use one more method here, which is storefront ensure. And what ensure is, it's an analog to Datomic's pull API. And when you run this, it will only return true when all the data from that has been loaded. So you can make a loading space, and you could have it make sure everything from what you're going to render is there before it renders the rest of it. So I'm going to skip over this and go straight to the demo for time's sake. But I'm going to demo an encounter where we talk about strep sore throat. So we're going to find a patient. John Doe is probably the one I'm after. He has a lot of encounters here. We're just going to create a new one. So now he has an empty encounter. And let's say he came in with a complaint of sore throat.
I'm not seeing that on the screen.
OK, sorry. So if I can get over here. All right. So we will get John Doe. We'll load a patient, John Doe, lots of encounters, create a new one for him, and we are going to add a complaint for John Doe. And we're going to say he has a sore throat. We see pain in the throat, and we entered this here. Now before, if you remember, one of those rules was to suggest a diagnosis from sore throat. And in this case, one of the possibilities when you have a sore throat is that it would be streptococcal sore throat. It could be strep sore throat. So I'm going to take that suggestion, and you'll notice that when I take that suggestion, more suggestions come in every other section of the encounter. And this is the interaction I want. Now, so he could just have tried that selection of the diagnosis, and maybe he's like, I want to say something more general. I want to say that's a streptococcal infectious disease. It's not about a sore throat. And so we can select that and remove the other one, and everything will be in the place it should be. Now it's not just, we have multiple levels for these suggestions, and the idea generally is the person who makes these UI widgets could support any kind of data they want to expose for the users. Any derived data the user wanted to make, they could expose. In this case, we have side suggestions for prescriptions. And we'll just do a amoxicillin. Now, amoxicillin, it's going to suggest us several dose categories. And we're going to choose just infection, mild to moderate. Didn't suggest anything here because in order to suggest an appropriate prescription, we need a weight for the patient. And we're going to enter 32 pounds, or 32 kilograms. And now if we go back to this context, we see that we have prescriptions that the rules had made that are pre-made to fit numbers that are easily measurable by the parent of this child or by the patient. And a lot of systems would just, in this context, they'd have some very long decimal number for you to round off. But they're carefully set up. There's often instructions in these suggestions, and you need but select, and you have it there ready to send if you wanted to. Now, another part of the story, I'm going to, let's see, say I go back to streptococcal sore throat. He changes his mind. He sees most of this information's here. Streptococcal sore throat, if we go back to the complaints section, is backfilling more complaints that are pertinent to streptococcal sore throat. So the doctor, rather than having to type each of these in, is able to primarily touch what he's after. And so just restless sleep, irritability, and we can go here and we can say, you know, change our mind that there's no pain in throat. Anyway, so we build up this data, and I wanted to show you one more example where we can see that we're going to do billing. And it so happened that our biller wanted to make sure that this physician was billing the right E&M code. And so she made a set of rules for him that's going to help him more easily find the right code. And so this patient's already been seen, so the rule is seen that the doctor has more encounters. And so it's not a new patient visit, but an established patient visit. And once you have that, it will suggest the diagnoses on the encounter to add to them. And if you open this up, it suggests a set of refinements to be more specific about what kind of visit it is. And you can see clearly, maybe this was a 10-minute visit, and it shows the doctor in line what the fee for the service would be. So that's a demonstration of the kind of interface we're after for the doctors. But the thing is, doctors could ask for anything pretty easily in the system, and they can make the rules themselves. So I'm going to take you to where the rules are made, at least one of the areas. And I'm going to search for demo, because we have a strep demo here, and the rules that target the encounter. And here we see more of the same that I showed you in the screenshots here. There's an encounter that has conditions that have strep throat, and then a lot of things that happen. So here's different complaints. Let's find one a little more interesting. Here we go. And so this is one that is suggesting the Strep Test. And so it's suggesting a procedure, this is a condition rather. And it's looking to see if a Strep Test has a diagnostic report and an observation of whether the strep is positive or negative. Now each of these things, basically you're able to click and edit them. So I clicked on this. I could choose a different kind of test, or I care about, I don't care about strep, I care about cough, and I can search for these different concepts. If I have time, I'll go back and show you a little bit of about the Unified Medical Language System, which enables this. So anyway, that, and you can click on, for instance, this. These are conditionals here. It means all of these things below it have to be true for the consequence to happen. And if you click in any of these contexts, you end up with all the attributes that are valid. So we said here we're basically building up queries, and these queries derive data. And so you're able to, since the schema of these things is fixed, you're able to discover the schema and build up these queries. This is very important. A doctor is not interested in remembering this name and typing it in, so it allows him to discover the shape of this data as he's using it. So another thing we do, because that is not always the best answer. Oops. I have an alert box on the other page. Another thing we do is we do what's called prototypical rules. This is where we have the doctor go ahead and do what would the ideal encounter be like for someone who had, let's say, a common cold. And so it's probably upper respiratory infection. And so the doctors went through here, and he's made his ideal encounter for what you'd need to know with an upper respiratory infection. And then we take these and generate rules from the data in the encounter. And the idea is to have a feedback loop back and forth where we collect knowledge from, one, these ideal cases the doctor uses it, to their actual use cases. Like whenever they search for something in that search box, it means we failed to suggest the right thing. And so we take that as an opportunity to improve our system and hopefully give them more time to look in the patient's eyes. And you can see there's many things. See, he made a lot of prescriptions here. Okay. So next we're going to go back to the presentation. Hopefully. So here's our progress report. Because of Storefront, we're able to keep our server-side code base extremely small. Our entire backend is 4,000 lines of code. And a lot of that is still mostly dealing with interop with other health systems that use SOAP and all kinds of stuff like that. Our front-end code base is 20,000 lines, which is more than we would want, but I think as we transition into some better use of React, we'll be able to make that smaller while adding more functionality. We've given the doctor a basic ability to be able to edit this knowledge and to play with it and to make an environment where he can explore these ideas and ways to optimize his experience. And we're just starting on the collaboration aspect. So those rules you saw made there, everything is content addressable, which means that if you create the same rule in any context, the leafs, they're going to be hashed to the same value. So if doctors accidentally make the same rule, it truly is the same rule. And this allows us to watch over time as this logic grows and see, likely a doctor, when you start out just talking about what we talked about before, whether they have strep, well, likely if he just looked at the condition, later on he's going to go and extend that rule to look at whether there was a procedure that had a result of a positive strep test as well. And so hopefully we should end up in an environment where we can continually grow this base and share across these users. And the idea is similar. Joe Armstrong from Erlang has talked about this. Like, what's the idea? How could we have this global database of functions, like to get out of that file abstraction and really share logic or code with less boundaries? Yeah, I explained the closed loop learning. Are there any questions?
So I'm assuming this is a commercial product. Is there any aspect of this that'll be, because I'm working on a very similar project, I wouldn't mind, is there any aspect of it that'll be open source and there'll be some way to collaborate?
Well, we tried to open source Storefront in time for the for the talk, but failed. So we'll see if we can get around to it. We'll try to make that happen.
So there's been a lot of, for like the past 20 years, NIH-funded work extracting information directly from text medical records, and so they're actually good corpora for getting structured information out of text medical records. Did you start with those as your sort of rule base instead of having everything be hand-entered?
Yes. Nope. So yeah, I skipped over this section because I thought I was going to be short on time. But there's the Unified Medical Language System, which is this is the terminology-based side. So a concept is basically an idea, and each concept has many ideas. So there's strep, sore throat. There's many different words for it. But the interesting thing here is there's 12 million relations to these concepts as well. So when I entered strep, sore throat, or streptococcal infection there, and the choice of amoxicillin was selected there, none of us entered that. We pulled that directly from UMLS. It has a set of suggestions of things that may treat different disorders. And so it's a hybrid. We're pulling what we can and adding what we can. Yeah, just to zoom in here, we have, this is kind of what it looks like. There's a hierarchy of things. So streptococcal sore throat is a streptococcal infection, which is a disease due to gram-positive coccus. Like, so what we're seeing here is everything that's true about streptococcal sore throat should generally be true of a streptococcal infection. So the rules can target something higher in this ontology and it apply to things below it. Of course, you don't always want it to do that because taxonomies are a challenge sometimes. But, and you can see here, if I click on streptococcal infection, these are all the different kinds of streptococcal infections that there are, and there's huge amounts. And so it's really a great tool to leverage for us. And, but any other questions?
What's your approach on like namespace in the rules? So if one doctor goes haywire and has all these ideas about how rules work, do other doctors see that, or otherwise, do they waste their work and each doctor has to write their own?
So the answer is we're trying, like I said, so the rules themselves are content addressable, and we get up to these roots that are like references, and we call them rule sets. And so these rule sets can basically be forked. None of this is really exposed to our UI right now, but we're trying to get it to a point where basically you can fork the way someone practices, make your changes, and we can diff them, and like I mean, it's a classic Git Git problem. So, any other questions?
We've run into issues, details, but we've run into issues providing recommendations in that you basically have two options. You either tell them what they already know, in which they don't think you've provided value, or you tell them something different, and they say, no, that's wrong, in which you haven't provided any value.
Correct.
You guys run into that.
Well, we took a different approach. Like, our goal is to tell them what they already know. Like, we're not telling them how to practice medicine. We're trying to optimize how they enter the information. So yeah, that was something something we were thinking about a lot in the beginning. But our goal is to increase their speed of information entry and give them options maybe they wouldn't have seen. But it's still a very doctor-driven process. Well, it needs to be encrypted at rest. Is one of the big ones. Code-wise, so storefront is a challenge to secure. So that's something that's an active problem for us. That is one of the issues that didn't get open sourced. So as you like I said, we were using OM cursors to build up these transactions, and you have a bunch of add and retracts. It's hard to know if that fits your security model. So we have some techniques to do it that are good, but we have something better coming up the pipeline. But just checking security models with something as raw as Datomic add and retracts is a challenge. Well, any other questions? Thank you.